Great. All right, let's go ahead and get started. Thank you all for joining. You all know me, Adam Householder, Commercial Strategy Manager for Fluke Renewable Energy. And then today we have our guest speaker, co-CEO, Steven San Juan. Many of you may recognize him from some of our marketing materials that we've already put out in the past, around the 393 and I believe the irradiance meter as well. Steven is the co-CEO of Rise Renewable Energy. Steven, you want to give a brief introduction of yourself and what you do?
Yeah, so been in the solar industry for about 10 years now, formerly in the Navy, and spent 10 years in solar in various companies, worked for the manufacturing side, worked in the service provider side, but always in a field service kind of application. And about a year and a half ago, I started Rise Renewable Energy, and we specialize in field service training. So we do primarily wind and solar, but we've dipped into battery storage and EV as well. But everything except field service. So there's a lot of companies that do field service great out there. We felt like the training side of things was a very absent market. So that's where we're at.
Great. And I didn't know that you were Navy. As a former Army, I apologize. I'm sorry to hear that.
Well, we can't all be perfect.
Can't all be perfect, right? Okay, for everybody that's joining in the audience, I'd like to first say thank you for joining. This is meant to be a Q&A session, as open-ended as possible with how many people we have on here. Let's please use the emoji to raise hands, and we'll get to each and everybody's questions. You can also utilize the chat if you want to submit any questions you may have. I can moderate and make sure that we're pitching those questions to Steven, so that way he can answer as much as we can. Steven, so you can get an understanding of who we have in the audience here. We have territory managers, district sales managers, we have channel leaders, we have national account managers, we have field sales directors, so most of all sales, and then we also have some additional marketing people that are joining us as well, and they'll be potentially asking questions aligned with their discipline. So just in preparation there for what you can expect. But I'll go ahead and kick it off with the first question. What currently is the buzz right now in the solar industry? What's being talked about? What's the main area of discourse that you're seeing?
As far as a business model, repowering the solar industry with how much it's grown over the last 40 years, utility scale being only about the last 10 years. I guess to back up a little bit, 10 years ago, what we kind of call utility was actually commercial and industrial. And then now we have all this, the mega plants you would see like out in the middle of the desert, hundreds of megawatts, thousands of hours. And because it's a budding industry, it's a huge investment opportunity. Everybody has gotten into the industry over the past, 10, 20, 30 years. So a lot of companies, they'll kind of sprout up, sell off, and move on with their lives, for essentially a quick buck. It's kind of I guess you could say, one of the downsides of free market capitalism. But having said that, you have a lot of manufacturers that just don't exist anymore. A lot of construction companies that don't exist. They built their projects, they came in, they left. And so repowering is now this concept of saying, okay, we have this aging solar infrastructure, and using that term loosely, because we're talking about sites that are 5 and 10 years old that are already getting completely redesigned from the ground up to maximize whatever lifespan they have left. So repowering is like the biggest thing right now.
Great. Is there, even though it recently happened, anything in connection with the Inflation Reduction Act, and any conversations that is spurring, or activity that's you're seeing your way?
So other than just challenges in hiring, nothing specifically about that, because also with things like Inflation Reduction Act, there was something like $800 billion set aside for solar, specifically solar and battery storage. So where most industries are suffering, solar is still booming, more so than almost all other industries.
Great. And you mentioned, I had this question a little bit later here, but since you already kind of touched on it, are there any significant technical or safety considerations or requirements that are different between the residential to commercial, industrial to utility solar that you would recommend we keep top of mind?
So both solar and battery storage, it all comes down to DC systems. Electrical for 100 years has all been focused around AC systems. Everything that you have in your commercial or industrial buildings has all been AC, it's just forever, ever. DC systems at the scale that they're currently at. So a few years ago, it was all 1,000-volt systems. Now they're going into 1,500-volt systems, or have been for the last few years. And there's a lot of discussion at the manufacturing side to step it up again up to 2,000-volt DC systems. So from a safety perspective, there is no real governing agency right now that has safety protocol for this scale of systems. So NFPA 70E, National Fire Protection Agency, designated by OSHA for electrical and fire hazards. They only just in last year's edition of the NFPA 70E included any mention of DC systems. So they're at least 10 to 15 years behind the times. That's how a lot of federal safety agencies are. So they're just now talking about DC systems, and there's not a whole lot of discussion, or at least I should say permeated knowledge as to, what that safety looks like.
Great. Question from Pete Stormer, Northeast Territory. What's required in testing and measuring for those quote unquote aging large-scale solar installations?
So I'll come to repowering in just a moment, but for just aging systems in general, a lot of it just comes down to maintenance. What kind of things from a troubleshooting perspective do I need? So if you ask anybody about insulation testing, they don't even know what insulation testing is. They call it Megering. So everyone just says, I need to go Meger the PV array. That's one of the most common troubleshooting methods for the choke modules at the inverter, as well as the PV array itself for ground fault. So ground fault troubleshooting is the single biggest thing that is done, as far as a troubleshooting perspective. You have an outdoor electrical conductor, it's exposed to the environment, whatever weather your region has, and being able to identify and troubleshoot ground faults. It's the largest part of the system, and it is the most exposed to the environment, which causes issues. So insulation testing is kind of like the number one. And there are a couple of different ways, like I said, high voltage insulation testing, 5,000 volts, 10,000 volts. And then what's becoming more popular is the handheld insulation testers that usually go up to about 1,000 volts from what I've seen. As far as the repowering things, it's all the same stuff you would do during construction. It's just now taking down a portion of the site and rebuilding it. So from a measurement standpoint, it would be all your standard commissioning checks you would take, installation of grounds, basic recommissioning type things of, AC and DC voltage checks. But the bigger challenge on there is going to be the re-engineering, of a project. So if I've got a 600-volt system that was built 10 years ago, how do I use that existing PV array with a new inverter? Or how do I use the older, use a newer high efficiency model that, built around 1,000-volt or a 1,500-volt design with modules that were designed around a 600-volt design? So that's kind of more the engineering perspective. And I saw the picture, the question of a choke module. An LC filter, just an EMI filter that's commonly used in power production. Sine wave filter, sinusoidal filter, LC filter, EMC filter, a lot of different names. But the choke usually refers to the inductor coil.
Thank you. I got another question. What's the best way to get knowledge about the NFPA 70E out to the companies?
So if you're going to be actually in field working, I would recommend actually doing an in-person instruction. They used to be a 3-day, so 3 8-hour day course, but there's a lot of online courses you can take through various learning management systems. Usually just a couple of hours that kind of give you an introduction to the concept of electrical safety, arc flash, shock hazards, what the boundaries are all associated with that. Small plug, we teach that at Rise. So if you're ever interested, we can do it both in person and remote.
Question from Gino Porter. Fluke does a great job with helping our customers creating reports that can currently be done with IR, industrial imaging, battery testing, power quality, and more. Is there a reporting system that will support our solar customers with, and is there a need for that? So you've got a little bit of experience with the new NPI that's coming, or the solar multifunction tester and the reporting software. You want to speak to that?
Yeah, as far as just reporting in general, right now it's very rudimentary, and this kind of goes into anytime you're talking to the average field technician in solar, the biggest problem that faces the solar industry from a hiring perspective is the industry is far outpacing the talent pool. There is a severe lack of people that know how to operate safely, troubleshoot effectively, commission these projects. And the big challenge is not that there's a lack of engineers in the world or anything like that. You end up with a lot of these utility scale projects are out in the middle of nowhere. Think about your wherever it is you live right now, and think, do you want to move out in the middle of the Mojave Desert and work outside? Probably not. So there's not a lack of smart people in the world. There's a lack of people that want to live in the boonies, in some of the harshest environments out there. And that's true globally. That's not just a problem here in the U.S. Largest solar project in the world right now is in the Sahara Desert, in the Middle East. So it's a challenge to try and find people that are educated and know what's going on. So having said that, when it comes to documentation, how are you going to keep track of the work that's being done? When your average age group is probably 18 to 25-year-old male, not college educated, but just looking for a job that's going to put food on the table. A lot of people that don't know how to use, high-end reporting software. It's like Salesforce is one of the big ones out there. I'm actually being commissioned to teach people how to just use basic Salesforce functions, just because they barely know how to use a computer for basic word processing, and now you have these kinds of things that are out there. So I forgot the SMF, the multifunction tester, the SMFT. I think it's a great start, but one of the biggest feedbacks when people see my water bottle, because I carry or know that I work with Fluke on a regular basis, is complaints about the Fluke Connect app. It is not easy to use for people that are just not familiar with kind of documentation and working with various word processing applications. And again, that's not just a Fluke problem. That's just kind of an industry problem right now.
Thank you. We've got a question from Jit Patel. Jit asks, what are some of the symptoms of ground faults?
So the most common one, at least as from, just, is there a ground fault? Did I get a notification that says there's a ground fault? Is the inverter, which is kind of the heart of your solar system. It's what's taking your DC and turning it into AC. They will have some sort of ground fault detection device. Older units typically had either a breaker or a fuse, so it would trip. Some sort of feedback would tell the inverter, hey, there's a ground fault, and then it would be up to that O&M technician or service technician to go out and determine, is it a PV ground fault, or is it an inverter ground fault, or whatever. As of the 2020 UL listings, it is now required to have a digital ground fault detection, so an actual circuit board that goes into it. And so that gives you a lot more troubleshooting functionality there. So as far as like indications you would get is, getting a phone call. So the inverter tripping offline with whatever fault code, is kind of unique to that manufacturer. As far as once you go out and troubleshoot it, the most common method is going to be a imbalance in your voltage. So now you have a DC system with no ground reference. In a perfectly insulated world, you would have even voltage, so measured from positive to ground or negative to ground. And when you have an imbalance, that is indicative of insulation failure. And then troubleshooting, there's a lot that goes into the kind of the troubleshooting of that, which we could talk about for hours and hours and hours.
Take you up on that at another time. What areas do you cover for your in-person training? That question coming from Maggie in the Ohio.
We cover a lot, anything from basic safety all the way up to more advanced technical corrective and preventative maintenances. We do up to manufacturer specific, as well as more general industry, Tech 1 and Tech 2, electrical theory, troubleshooting, and so on.
And this could be in reference to you or to those other companies in the industry that you may have some awareness around. But how do you find out about new products in general?
So the industry kind of, it's a very reactionary thing. A lot of the times when you have a service team, it's just whatever project I happen to be working on and do a lot of Google research. And so one of the biggest problems that I see right now is that over the last 6 or 7 years, when the 1500-volt systems have become more and more prevalent, a lot of people just look up 1500-volt meter. What 1500-volt meter comes up, and 6 or 7 years ago, the first one that came up was like the AmpProbe HD160 or the HD110. About 4 or 5 years ago, it's been the Hioki. And then it comes down to price tag, which one's cheaper, and the Hioki is universally cheaper than pretty much everyone else on the market. So yeah, it's kind of, you have a lot of guys that don't necessarily are not well educated on what meters are available or what tools are available. It's a highly reactionary, word of mouth. Hey, at this last company we worked with, they had this. I can't count the amount of times I've gone to a job site and, hey, what's that in your tool bag? Does that do what we need it to do? Do you mind if I, grab it for a second? Oh my gosh, that's amazing. So it is very much word of mouth, and Google research.
So you mentioned it's highly reactionary. Are there any specific features or functions or capabilities that would come across depending on the product that is being looked for, or solution that's being looked for?
So as far as functionality, most handheld digital multimeters do what you need it to do. Voltage, current, resistance, capacitance. That's sometimes a little bit harder to find. Excuse me. So yeah, doing a farad measurement for an inverter technician. And as far as, kind of not necessarily a daily measurement, but insulation measurements, being able to measure insulation resistance for your PV array is something that's, like I said, it's like probably the single most common failure that you end up having.
Great. Going back to your statement about being reactionary and searching for the products on a as needed basis. Are there any distributors or sellers out there that are providing additional value to you as a customer that kind of point you in their direction when you are doing your initial research?
So there are some out there, but the biggest problem again is education on the products themselves. So a lot of the stuff that they're pushing is the same stuff they've always been pushing, or so like, again, one of the biggest mistakes that I see as it relates just to standard digital multimeter, what am I going to use or try and use as far as, a one-stop shop, so to speak. As a technician lead or a manager, you don't want to buy 5 or 6 meters to get the job done. I mean, you could, but you want to find as close to one as possible. And most people lean on that Hioki. I forget the model number off the top of my head. But the problem with that one specifically is it's only Cat 2 at 1500. That's actually 1700 volts. So a lot of people, when they say this is what we're using, they don't even know that it's not rated for the work that they're actually doing. So because it's so reactionary and because there is not a, there's not a really good knowledge base as far as what do the category ratings actually mean? What is this one versus that one? A lot of guys will buy a meter because they just need something that they know says 1500 volts, but then they go back and say, oh, it's not rated, to do the range of capacitance that I'm doing, or the range of current that I'm doing, or it doesn't fit in the box that I'm using. And almost every group of technicians that we have come through and we teach, they almost all have a personally bought alternative to the one that's provided to them to kind of do this relatively unique thing that they're doing.
Can you go into the separation or differentiation between category 2 and 3 and the impact that it has on you, especially in regard to safety, since that's the area that you're specializing in?
Well, speaking, preaching to the choir here, the category ratings are everything when it comes to one half of everything when it comes to the meter. Is the meter capable of safely taking the measurement in the environment that you're taking the measurement in? And the IEC, the International Electric Code, signifies all utility scale solar as category 3. So all of your DC systems, both commercial, industrial, and utility, are category 3. And that is like the best kept secret when it comes to utility scale solar.
All right, so there's certainly a point of emphasis that we should be driving home. Yes. From Tom Grubb, our merchandising manager, how do we promote and create awareness about our new Fluke solar products through training?
Well, training in general, unfortunately, there are not very many training organizations that specialize in renewables, and that includes both wind and solar. That's actually one of the things that we have come to, me personally, I knew that solar training was needed. But there's just literally, if you just go do some Google research, try and find any organization that does solar training, it is almost impossible to find. They just don't exist right now. So from a training perspective, yes, that is a part of all of the training that we do, even though it's not directly related to most of the training that we are actually doing. I'm teaching people how to troubleshoot, do corrective and preventative maintenance. Typically, when you're doing that kind of training, there's an assumption that there's a general level of knowledge that what kind of PPE you would need, what kind of meter you would need, or what kind of tooling that you would need. We've kind of come back a little bit and added that into a lot of the content that we teach because it is so unknown right now.
Follow-up question from Pete Stormer. What tools and functions, and I'm going to expand on Pete's question a little bit, what tools and functions are important to the residential, light commercial, solar installers and technicians? And if you could take that question and apply it to commercial, industrial, and utility as well.
So as far as residential, most meters do what residential technicians need. Now, I am not a residential worker. I'm familiar with the design. I'm familiar with kind of the theory behind it, but I know the biggest problem with solar guys is actually not the electrical side, because again, you're dealing with a much smaller system. Still, a lot of residential solar systems are still 600 volts DC, so it's not difficult to deal with or find product that kind of supports that thing. The biggest problem facing residential is actually working at heights. People falling off roofs because they have no idea what the appropriate way, the safe way to work at heights is. Now, as far as CNI, that's when you're starting to dip into 1,000 volt systems. but there are a lot of solutions for 1,000-volt meters. So utility's the big one where you now go into this 1,500-volt, which even though it's been around for 6 or 7 years now, I want to say 2015 was the first installation with the 1,500-volt inverter. Might have been 14, but 6, 7, 8 years later, a lot of people still don't know what kind of requirements are there. Now, as far as, let's see, the tools functions are important to the residential electric solar installers and technicians. So as far as functions, like I said, the voltage rating is going to be one of your biggest ones. You have to be able to measure voltage, and you have to be able to measure it safely. Cat 3 at 1,000 and Cat 3 at 600 are easy to find. So at the utility level, it's going to be that Cat 3 1,500. And then both C&I and utility, if you're looking at an inverter technician, so someone who's going to troubleshoot and maintain the inverter specifically, it's all your standard measurements: voltage, current, frequency, resistance, with the addition of capacitance or farad measurements. Residential, I would assume it's the same, but most inverters are just individually replaceable. So you're not actually troubleshooting individual components in the inverter. It's just replace the whole box. As far as in the PV array, voltage, current, resistance, but now you're talking about high voltage resistance checks. So an actual insulation measurement of some sort.
Your comment there about residential and just replacing the inverter, do you think that that's a dynamic of the lack of maturity in the market right now, and that we will potentially see that shift to troubleshooting those points of contact?
So most residential is shifting over to micro inverters, and they are literally designed just to be individually replaceable. The micro inverters where you have one inverter per solar module, they become really easy to troubleshoot, and they are far cheaper and there's not much to repair in there unless you're like a micro miniature repair where you're actually going to tear it apart, individually replace a capacitor, resistor, or transistor, something along those lines.
Great. From Jeremy Creech, how are solar professionals currently hunting for ground faults on large solar systems?
So unfortunately, with as common as they are, the knowledge of how to troubleshoot them is severely lacking. So a lot of it is very rudimentary. I know back in the Navy, we called it ground pound, where you keep energizing the system, just isolating a smaller portion of the system, re-energizing it. If your if your fuse blows or if your ground fault circuit breaker trips, then the ground fault is still present. So you isolate another portion of the system and keep going. Companies that are better at it, there's a couple of different ways you can go about it. So insulation resistance, if you're at your central inverter and let's say you have 20 string inputs, I can go and, typically at night, disconnect all of those inputs, do an insulation test. Whichever one has the lowest resistance is, most likely going to be your fault. So that's probably the most common. Most companies are doing that right now, where they will wait until night, little to no voltage on the array, do an insulation test. It is becoming more common for passive insulation testing systems. So I know ABB's got one, Bender, it's a German company, they've got one on the market. But basically it uses the existing voltage and, does some of, the proprietary magic to tell you what your insulation resistance is. And those tests are usually done as a preventative measure, every morning before startup. Voltage checks. So like I said, if you have a floating array, so like your ground fault device is tripped, my array is now floating, no ground reference, I can use just a simple voltage measurement to determine which area of the system is faulted. With no ground fault reference, wherever there is a ground, because you have lower insulation resistance, it'll draw either that positive or negative ground measurement down. And you can actually do that troubleshooting all the way down to the individual module and actually, find out what your fault is. Another big one is current measurements. So with a ground fault present, you can actually use an amp clamp on the at the combiner box level, which are the switches inside the field, and amp clamp individual strings to see which string has current when it's not supposed to. That only happens with when a ground fault's present. So it's kind of the big insulation measurements, voltage measurements, current measurements, and then the ground pound method, or an existing, passive insulation tester, I'd say are the kind of common methods.
Great. Biggest differentiators for you between ground-mounted arrays and rooftop?
So from an engineering standpoint, rooftop systems and ground mount systems are the same thing. They're fixed arrays, as in they don't have any moving parts. What additional questions do you have on that as far as like a challenge with them, or?
And any key considerations that our people could go into conversations with, understanding different dynamics for customers that may have arrays that are solely rooftop, or if there are those that are solely ground mounted, and any additional information or context that you would encourage incorporating into those discussions?
Well, most of your rooftop or fixed array systems are almost always nowadays C&I, so the commercial and industrial. So it's not so much the problem with those systems is almost never the meter that you're using. It goes into the wire management behind them. If you've ever seen like a rooftop system, fixed array system, they're usually as close to the roof as possible. So there's very little workspace in there. So it just becomes a challenge. You're, zero shade, trying to, put zip ties on your module wiring, and it's a pain. But, from a measurement perspective, a solar module is kind of a solar module, whether it's on the ground or on a roof.
What about voltage thresholds?
So no, they're all the same. So you have three big kind of markets right now: 600, 1,000, and 1,500. And I see someone asked about how far off is the 2,000-volt system. As soon as next year, as far off as 10 years from now. As soon as someone gets a working array that is able to do it, they will likely go and do it. So there's already discussions. There's a lot of engineering discussions around the 2,000-volt system, but to my knowledge, no one is selling a product as of today for it. They're just all discussing it.
A question from Rick Kleinow. Are thermal imagers used in the solar workflow? If so, where?
So, okay, so I was told the electrical connection. So thermal imaging is very common. So right now, when it comes to array troubleshooting, so it's not so much ground fault troubleshooting, but just identifying, is there issues in the array? Drone thermal imaging is like the most common right now. Get a drone, attach a thermal imager to it. You can program using, like your GPS mapping, and go and do, megawatts in the amount of time that, traditional IV curve tracing would do for an individual or group of combiner boxes. There's also some sites that, even in the event of a ground fault, they will just, hop in a buggy using a, standard handheld thermal imager and just, shoot the array and see where there's either a hot spot or a cold spot. As far as the question on the combiner box, yes, it's done, and it's done all over the place. And depending on the level of knowledge they have, it is done to varying degrees of success. So yes, there is a theory talking about full swings from, load to no load, as compared to like standard or traditional power production. Like if you think of like nuclear or natural gas or something like that, solar has a much bigger swing through the average day for, heating and cooling your connections. So anytime you heat or cool something, it can, expands and retracts. So absolutely, loose connections are a problem. Usually not a fire hazard, although a lot of fires do happen on solar sites. But usually the ones due to loose connections are at the inverter level, usually when someone replaced it, not because of, just coming loose over time or degradation over time. If I go and replace a circuit breaker and don't torque anything down, I'm going to cause a fire. As far as thermal imaging and what it looks like, you either have companies that do it just to kind of have a check in the box, but don't do anything about it. The only imager that I know that is currently used that actually gets the job done correctly and safely is the TI 480 Pro. Because it has a high enough definition from a big enough distance where I can remove all the safety coverings, take an accurate image, and it'll give me a high enough quality that I can identify one component versus another. Whereas a lot of like your cheaper, cost-effective thermal imagers, they don't give you a high enough granularity of an image to take it to do it at the distance you would have to do it safely. So either they're doing it unsafely or they're just not getting the images that they actually need.
Can you explain why measuring the degradation rate of a PV system is important leading into IV curve tracing here?
So for IV curve tracing, 10 years ago, there was the initial thought that solar modules would degrade somewhere between 2 and 3% every year. So year over year, if you have a 400-watt system, you would lose approximately 2 to 3% of that every year. And that was built into the initial calculations of what maintenance you would have to do with that or what kind of component replacements. Since IV curve tracing has become more prevalent and some companies are doing it, like Southern Power is like one of the few that I know that 100% of their strings are done every year. They're finding that 2 to 3% number is closer to 4 to 5%. And in some cases, depending on the manufacturer, as high as 6 to 7%. So long story short, when you're going to build a project, if you're not accounting for this now, let's say 5% number, and you're still using that older 2% number, you're not going to actually be able to predict the 20 to 25 year lifespan. So IV curve tracing, that's really the only way that I know of how to do it. It is the only way to do it to actually determine what that year over year degradation is with your solar farm.
And how often are those tests being performed?
Most companies do, like 10% every year. That's probably like the industry average. Like I said, Southern does it 100% every year, and then there's other companies that don't do it at all. But I would say on average, 10 to 20% of the system every year is done.
From Brandon Good, how many technicians or workers are needed at large, medium, or small utility solar farms to maintain, and how many techs would be needed at the construction phase of a project and would potentially need meters or other troubleshooting tools?
As soon as you find that answer, tell the whole industry. Short answer is nobody knows for sure. It is still constantly changing and being discussed. 10 years ago, they thought it would take, one person per about 5 megawatts. Now they're finding that it's more, closer to one person for 40 to 50 megawatts, as long as they're not doing some of the larger maintenances. So there's a really big industry for subcontracting some of the more labor-centric seasonal work, like let's say vegetation management or panel washing. But yeah, as far as like the actual number, your guess is as good as mine. And again, it all depends on kind of what the full scope of work for that system is. Now, as far as the construction phase, again, that number has changed a lot, but you're easily talking, and again, it changes because of how fast you want to get the project done. If we've got a tight deadline, they will throw many millions of dollars at it. But yeah, you could easily have hundreds of technicians on a 100-megawatt project, or hundreds of technicians per, or I should say electricians, because most of the time it's the union that's doing it. And as far as how many people need the meters, I'd probably say 20% of your construction teams. It's completely off the top of my head, but most of the labor cost when it comes to construction is the physical installation, people picking up modules and bolting them onto a frame. Obviously all the heavy, equipment, the trenching equipment, the pile equipment, and so on. Obviously, they don't need meters. That's all done, as de-energized as you could realistically get. So usually it's only the actual commissioning teams that need meters. And, say 15-20% of the overall construction team would probably actually have a meter.
Great, thank you. What does the current method for reporting and certification look like? And what are some of the key challenges faced when it comes to collection of that data, asset management, and communication of those reports?
I'm sorry, I completely brain farted on that first part of the question. Could you repeat it?
No worries. What are the challenges that you see or that you run into when it comes to reporting and certification on these PV systems? When I'm saying reporting, like the customer reports, what information is being shared with the customers?
A lot of it depends on the contract. So there's usually going to be some sort of like service report, basic like after action report. Hey, we did this, whatever that is. And then anytime when you're doing like a corrective maintenance, then it's going to be, out and in what was done. Thermal imaging, you're gonna have a picture of, whatever the thermal image is, as well as kind of what the recommended solution is, or, what was found. This is obviously faulty, this is obviously good, that kind of stuff. The challenges, I would say, is the lack of standardization. You have some companies that are really good at it and have really detailed reports, but most companies right now that are doing this on a contract basis, it is very rudimentary. I mean, you have a lot of guys that are going in the field with pen and paper, like literally pen and paper, to go and document this stuff, and it's being transcribed into, an Excel spreadsheet. Snapshot of that Excel spreadsheet goes into the final report. And like I said, it's very, very rudimentary. And then the lack of knowledge of how to interpret. So like, for example, an IV curve trace. Most people know what an IV curve trace is, but as far as how to actually interpret it or do anything with it, don't really know. Same thing. Most people know what a thermal image looks like. It's hot, it's not hot, but as far as how to identify a failure, or if it's just, hey, it's a power production unit and it just on average gets hot. And again, this comes back to the general lack of education in the industry. You have a lot of, typically young, typically male, don't have a college education, don't understand the engineering behind it. They're just, go put a square peg in a square hole.
When it comes to, you've had your hands on the SMFT 1000, correct?
Yes.
Have you had a chance to see the True Test software or the beta version of that UX?
So I did not get a chance to play around with it much, other than just kind of screenshots of what it looks like. So at a very high level, it looks good. But I think it will have the same issues that a lot of other, so like Maximo or Salesforce, or, even other form platforms like a Go Forms or a Pronto Forms, is the more it is capable of doing, the steeper the barrier to entry is going to be. So again, if I've got somebody who, 18 to 25-year-old male, not super familiar with computers outside of TikTok and their phone, how are they going to be able to now kind of interpret this and do this? So in the hands of a more seasoned manager or technician, absolutely, on the surface, it looks great. I think time will tell as far as kind of the rest of the industry as it catches up, as far as the actual technicians doing the work.
So we need a series of episodes on TikTok of how to use True Test. Is that what
Yes,
you're saying?
yes, that would be outstanding.
Perfect. And as for the mainframe or the aggregate value of the SMFT 1000, from your perspective, what are the most impactful features or functions of this solution to either you or that you see for your customers?
The IV curve tracer. If the price range stays the same as what they were talking about when we were doing the marketing stuff for it, as far as I know, it'll be the cheapest IV curve tracer on the market, and that by itself is a huge one. The downside, though, is it's only 1,000 volts.
To that point, what information that we've gotten here is that the 1000 volt tool, while not ideal, it can still be used in that 1500 volt architecture with the proper steps being taken, i.e. splitting the array and testing two sides of it.
Yeah, and then the problem with that is now it's going to be a procedural thing, and when you already have a lot of companies that struggle with basic procedures, like a basic lockout procedure, a lot of those testing procedures are now going to become a challenge to adopt more industry-wide. Now, engineering firms that do that, and like that's their, that's kind of their bread and butter, absolutely, they won't have any issues with that. The challenge is obviously going to be, though, how do you get it a more wider adopt rate?
Well, we are at time. Really appreciate you making yourself available for us to pepper you with questions here for the last 45 minutes. I got a ton of value out of this. I'm sure many of those on the call did as well. We'll make sure that this recording is provided to everyone afterwards, and then two, we'll make some additional sales enablement resources out of this. For those in the audience, please, if there was anything specifically impactful to you that you would like to see content or materials made to address, please let me know, and then we can start working on it. So again, Stephen, thank you so much. We'll have a swag bag sent your way promptly. I'm aware of your preferences, so we'll make sure to take care of you. Again, thank you, and thank everyone for joining. All right, that'll do the call.
Thank you.
Have a good one.
Yep.
Hey, Adam, you still there? Adam.